Okay, so my name is Simon. I'm a software developer at Ericsson. I'm working on a project called Eclipse Trace Compass. So it's a trace analyzing tool. So today I would present how we were able to make a front end with Theia for trace visualization. So I'll talk about what is Trace Compass, what the evolution of Trace Compass were necessary to move to Theia, for example. I'll present the trace server protocol, also what opportunities Theia brings for us, and I'll show the prototype I have for Trace Compass in Theia, and also if there is any question at the end. So what is Trace Compass? So it's an open source application to solve performance and reliability issue by reading and analyzing traces and logs of the system. Its goal is to provide views, graphs, metrics, and more to help extract useful information from traces in a way that is more user-friendly and informative than just a huge text dump. So a bit of background. So what is tracing? So a trace is a series of events over time, and the events are collected at trace point during program execution, and each event has a type and a payload that can be useful for further analysis. So you take these events as input for analysis, and these analysis can be used to create all kind of visualization graph, like XY time graph stuff. So this is some image of Trace Compass right now in Eclipse. So the tracing helps developers and troubleshooter or system administrator to find and solve complex problems. So here are a few examples of what you can do with tracing. So you can profile your application, you can find long execution, investigate real-time deadline, find memory or load issue, and also investigate concurrency problems. So now let's talk about the architecture of Trace Compass. So we went from like a classic Eclipse application, a monolithic application, very highly coupled, to a more layered architecture where the UI and core are decoupled, and we use what we call data provider as a common way to pass the data between the core and the UI of our application. So this is the current architecture in the Eclipse project. So from that architecture, the goal is to separate the front end and the core completely by using what we have right now is the trace server protocol to communicate the data between the two parts of the application. So for example, we can have like a trace server that is composed from the core component of Trace Compass and the front end using Theia. So last year we introduced the trace server protocol to be able to plug, I can say, the Trace Compass inside the next generation IDE. So like in the new era of Theia and VS Code, like we have the LSP, the debug adapter protocol, and we needed something for tracing. So that's why we have the trace server protocol, or TSP. So this is great for modularity. So now a more in-depth view of the TSP. So it's a protocol built to handle the communication between a backend and a front end of a trace viewer. So it allows traces to reside and be analyzed on the backend. It exchanges visualization data between a client and a server. It can also do some trace management, server-side filtering, and searching on large trace file. The protocol is currently available on GitHub. It's still a new protocol, so any contribution or feedback are welcome if you are interested in tracing. And also to facilitate the integration with Theia and the adoption of this protocol. We have a TSP-ready client that makes the request for you. It's just easier to use. It abstracts the technology we used. So right now it's REST or in HTTP. It can be switched to JSON RPC, and it will be transparent for the user. It's available as an NPM package for all your JavaScript and TypeScript projects. So you can have. So this is the link to the GitHub. So now let's talk about Theia. So the opportunity for us with Theia is like we can have an integrated feedback in design workflow. We can leverage the LSP and debug adapter protocol. We can integrate in continuous integration environment, integration with bug report tools, integration also with workspace management like Eclipse higher scalability and performance, and we can also leverage modern UI for all the visualization stuff. And also one important point is security. So I go in depth in all of these categories. So we can integrate trace analysis and visualization in the normal developer workflow. So we can design, you can implement and build your code, and then run some test case with tracing enabled, and then you can get the result back in the same IDE. So that's a workflow that we still want to support. One integrated environment for faster development and better productivity. The second point is we can leverage the LSP and the debug adapter protocol, because sometime in the traces we can have information in the payload. For example, you can have the addresses, you can have call site, you can have or plain name of the file and the line. So we can use the debug adapter to retrieve the file information for the addresses and the call site, and we can also use the LSP to jump to the right place in the code if you have the code open in Theia. And also in the future, we can also contribute back to Theia or the LSP by you have like the execution of your program, so you can use that to add code coverage or code annotation in Theia, so we can have like communication between those things. For continuous integration, with more like the philosophy of Theia, we can integrate our tracing in some continuous integration environment. So someone can submit code, you can trigger your build, you run all your test cases with, for example, with tracing. You can post the trace to the trace server and then analyze it and then show the result as a dashboard, or you can spawn the Theia IDE and look at the result. So the important thing here is that sometimes traces can take time to be analyzed or stuff like that. So this is something that can be run like overnight, and you get the result, and everyone get the same result, and the analysis is already there and ready to be looked at. And also when you open the Theia IDE, you can even jump at the interesting place in your trace, and everything is just ready for the user. And similar to the CI, we can also integrate with bug report tools. So if people can, like if a user enters a bug and they give a trace in the bug, we can do the same process, like posting the trace on the server, analyze the trace, and then show the result in the tools. Or you can, like the support person that will handle the bug can spawn the Theia and then look at the trace, for example. So it's the similar thing to continuous integration. We can also integrate with workspace management, so we can easily prepare the troubleshooting session. So we can check out the code, we can set up the appropriate LSP debug adapter if necessary, and all the extension and the trace server you need for that kind of trace or that kind of problem you want to solve. And one cool thing is in the future you can share your trouble session, because it's kind of time consuming to find problem in traces. So if someone can reuse what another person did, it's saving time. So you can share your workspace or your troubleshooting session. And also higher scalability. So it's enabled microservice, distributed architecture, also parallel analysis. That's cool because sometimes, like as I said, the analysis can be quite long. So you can distribute that and perform the analysis on different traces or on the same traces, but with like different analysis module. You can even throw like AI in that to find outliers in your traces. And also you can analyze traces that exceed local disk space, since traces can be very huge. Other opportunities are, as I said, modern UI, so better visualization library that already exists. We can have a thin UI client, so all the heavy work of analyzing a trace can be done somewhere else. We can have a lightweight single function trace server. So if you have a particular need for one analysis, you can make just one quick server for that. You can have a server and client in different languages to consume the analysis, or the other way around, consume the UI. And also the improved security, since the trace is not on your local machine, like all the information, because the trace can contain sensitive information, so everything is not on your local machine. And the way that the trace server protocol is designed is that you send only the needed information for the visualization, so you don't pass the whole trace to the client. And also one bonus is that maybe sometime we can trace and analyze Theia in Theia. So the benefits for tracing, it's also easier for people to access the trace with workspace management, and since the trace can come from different sources, it's just easier to access your trace. Right now it's a bit weird. Better visualization, better user configuration, so better user configuration. You can also simplify the trace analysis creation, because right now you need to make an Eclipse plugin and stuff like that. So in this case, it's easier to maybe just create a small trace server and plug it in Theia, so it's easier. It's more accessible. We can reuse analysis, so all the analysis made by other people's, that, for example, all the trace compass analysis that are already there, we can reuse that, and I will reuse that for the demo. And everything is accessible in one environment, so it offers more flexibility and modularity, so you can change the server easily, for example. So now let's jump to the prototype. The image is a bit blurry, but this is a prototype that I've made from using the trace server, the trace compass core component, and the Theia front end, the Theia extension. So of course, it's an opportunity for new UI and UX, because right now in Eclipse it's not the best. It uses React for the layout and stuff like that. I'm using Chart.js for XY chart. I'm using AG grids for the tables, and also a new time graph library made in collaboration with Typefox for like these kind of graph. So now let's do a demo. So now here it's a plain old Theia. Right now it's just the core functionality of Theia, so I don't have everything. So you can open, like here it's a kernel, it's a kernel trace from the Linux operating system. So you can open a trace. So in this case, you'll have a new widget on the side. So you can see your traces, you can see all the available analysis for that trace. So you can, for example, add XY for CPU usage of your trace. So now you have like all the information. You can also add, for example, the histogram for the events. So now you have that, and you can like add or remove analysis easily. You can also, like this is an example of a time graph. You can take it. So right now there's a lot of information, so you can zoom. Sorry, it's kind of hard with the touchpad. So you can zoom, you can do time selection, and everything is synchronized between widgets. You can also like pan in your trace. Whoa. Okay, so you can like pan in your trace, and the trace server, the TSP will fetch the data as you move in your trace, so you get only the required data for this particular time range. So we can add also another, for example, time graph here. And we can also re-add the histogram. So we can have everything in the same view container, so everything is aligned. And when you select, like all your widgets are like synchronized across the view. So, and also you can also, if you want to check your events in your trace, you have a table here with all the events if you like to see the raw data of your trace. So, and you can also reorganize your widget inside the container. So I think that's it for the demo. So the next step, it's of course more integration with Theia. So configurable option, for example, editing a JSON config file to personalize how you view your trace inside the Theia. You can also, the next step is to automatically launch the trace server when opening a trace, similarly to how LSP works. So you can start the server when you open a specific file. Also a backend module to detect traces. And one important thing is to save the current state, like when we refresh or when you lose connection, because right now you lose everything from UI side. And of course, the usual improve UI UX is in still prototype, and performance also, so, and many more. And just one last thing before I conclude is why we choose Theia. So the extension system offer great flexibility to build anything like we wanted. Like you saw, you can do some crazy stuff. It's open source, so we can contribute back. We have the choice between cloud and desktop, because sometimes people prefer desktop for analyzing traces. And also it's a growing ecosystem, and interest toward Theia is like we saw in the past days. And one last thing, I just want to thank the community for their work, and I'm looking forward for more Theia. So you can have all the information here, and if you are interested in tracing, I'm open to discussion and feedbacks on everything I talked today. Any question?
One question: how much insight over the data does the front end have? Does it get, for example, a bitmap to draw directly from the backend, or does it generate the graph locally?
The way the trace server works is like, for example, you have a time range, like the time range you see in the Theia. So when you do a request, you ask for this particular time range, and the server will compute, like for example, XY, you get like all the X value for the time range and the Y value. So it's easier, but for the example time graph, you get all the rows and all the states for each row, and only what you see. So there's not a lot of information passed between the client and the server. So it's
so if I understand that right, the protocol is not the trace server protocol is not based on interactions, because the graphs could be, you could add more graphs, so the interactions would be different. It's kind of like different from LSP, where it basically is like you do control space and something happens, and it's bound to that UI.
yeah, the TSP is just to request the data, so it doesn't handle any kind of like all the widget as its own like provider for one particular view. So what you mean is like when you interact with one graph, it doesn't affect the other, or I'm not
no,
sure.
what I mean is the protocol, the trace server protocol, is that based on interactions in the UI, or is it? Do you need to understand the data that's being sent?
You mean from a client perspective?
Yeah, does the protocol know about how the data is structured? Or is it more like, for example, debug adaptive protocol doesn't know anything about types, or if it's an integer, it just, here's a string, display that. Is that similar, or is it?
Yeah, it's a bit similar. Like we, for example, right now, the way it works, we have like endpoints for XY and for states. So you know you expect like states, but you can do whatever you want with it. Like it's the same thing as XY. You can, right now it's represented as a plain XY chart, but maybe like that's something in the future, like maybe you want to configure more your view, so the data can be used to like populate like a pie chart or stuff like that. So it doesn't give the exact thing to show, it's just like this is the data for this particular analysis. So like the CPU utilization, the memory utilization, or like resource and stuff like that. So it just gives the data, and then you can do something with it in the client.
For example, it would be possible to extend the protocol so that you get like a reduced set of data points to process on the client. If you know that you have to draw, for example, quite large time range, so maybe you want to perform data point reduction on the backend first before you send them to the client to improve performance. So, but this is not the way it works now, I guess. So but the entire data set is being sent to the client.
Yeah, but you can do whatever you want in your server and your client, as long as you pass the data in a way that respect the TSP. So you can, for example, at the university in Montreal, they have like a Python client that just consume everything from like an analysis that produce an XY, and they can run machine learning on this particular set. So you can do whatever you want with the data, as long as you respect the protocol.
So LSP and DAP are well established. They are used across many IDEs. I wonder what's the current state of TSP. Have you seen any other proof of concept in other IDEs, for example, Visual Studio Code?
Yeah, the TSP is really new for tracing. So we started like a year ago. There's not a lot. The goal of the TSP was to be used in any IDE, but right now we use it in Eclipse. We have like a prototype in the Eclipse environment, and we also have one on Theia, but I haven't tried it with for example, VS Code or stuff like that. So it's still new. That's why I'm asking, like, if you are interested in tracing and stuff like that, I would like to have feedbacks and stuff like that, and contribution on the TSP level, so that it can become more stable.
Out of curiosity, why have you chosen to do the prototype in Theia over Visual Studio Code?
Because like the visualization in Visual Studio Code, it's like you need to like do it in the web view, so it's kind of difficult to do. Like with Theia, we can have like the view I showed with all the analysis, the custom widgets, and we can have the editor with all your analysis in the same view. And I was not able to do it in VS Code. Maybe there's a way, but like I said, the philosophy of Theia with having like separate front end and back end is really useful for, like all I said, the continuous integration and having your trace analysis somewhere else. That's
Thank you. The last question also, how chatty is it? So for example, debug adapt protocol is quite chatty. It's sending lots of requests. I wonder how it looks for the TSP. How much data is actually sent?
Like I said, it's not that much. Like if you because we sample, like for example, the time graph. Even when you zoom out, like when you're totally zoomed out and you see all the trays, you don't get all the information of the trace. It's like we have a mechanism to be able to not show everything because it would be too much for the user. So it's not that much data. I have the numbers on my computer after if you want to see how, because we tested with like a JSON RPC, JZip and stuff like that to ensure that we don't send too much or it's not too consuming for the bandwidth.
Thanks.
Mm-hmm.
So the server does this sampling. So if I implement my own server, I will need to re-implement this thing again.
Yeah.
Okay.
It depends on your server. But in the TSP, like we support, for example, resolution, so you can, like you can pass your data, like you can make a request to tell the server. If the server doesn't support it, it's okay. But like we made sure that we have all the information, so we can do that if you have your custom server. For example.
So what are the next steps with that? Is it going to be productized? Is that an internal thing? Going to offer it to end users?
Right now, the prototype is available on GitHub. I mean, it's open to everyone to try. And yeah, the goal is to eventually have like a fully functional trace compass on Theia. So at some point,
But as a open source project for the community, or
yeah.
Sell that or provide it to end customers as actual trace viewing tool.
It's similar to what we have, for example, in Eclipse Trace Compass right now. So we have like the core component and the basic analysis, for example. Trace Compass support out of the box like LTTNG or kernel trace and user space traces, and this is open source, and we want to stay open source. So like everything I showed, it's open source, and we have customization for internal client. But that's so the core will always remain open source. So it will be available to anyone in the community.
It would be included in the packages that are sold to customers or something as visualization tool.
Yeah, it will be included in tools in the future, yeah.